Okay, good morning. Good morning again. So today, till yesterday's class, we have discussed isometric projection, 30-degree projection, three-dimension projections. We have discussed, including individual solids and three dimensions of solids, as well as a combination how to draw the isometric projection. We have discussed that. So now, once again, we'll go back to the orthography projections. So we started from projection of points, dimensionless object, projection of straight line, one dimension object we have discussed, projection of planes, two dimensions we have discussed. Now one more dimension I'll add to it. So that is the thickness or the height. Okay, that is nothing but your solid. So let me give you a introduction about this solids before starting. A solid is a three-dimensional object which is having length, breadth, even thickness or the height. Any object which has got three dimensions, okay, we can call that as the solid. So in this the particular chapter, our object is three-dimension object which has got length, breadth, and even the thickness also. Similar to the projection of planes, here also we will take any one of the three-dimension object and we'll draw the true shape diagram in initial diagram. Next, inclination with respect to HP, and then inclination with respect to VP. Like this, in three stages. Here also we will draw the projection of solids. Okay, this is regarding solid. Is once again I'm repeating. It is a three-dimensional object which has got length, breadth, and even thickness of the height. So in solids, the examples for solid, as I told, any object which has got all the three dimensions, we can call this as a solid. We will discuss here also some standard regular shape of these solids. All the prisms will discuss, and all the pyramids also will going to discuss. Okay, so let me take the pyramid, the example first. You know how the pyramid looks. So already many examples also we have discussed. How to define a pyramid. A pyramid, all of you know, in the isometric also we have discussed. Pyramid is a base. Any pyramid, irrespective of the type of the pyramid, it has got a base. Whether it is a square pyramid, rectangle pyramid, or pentagon pyramid, hexagon pyramid, or triangle pyramid. So all types of pyramids will going to see it is a regular shape. So it has got a base. Okay, and then so after joining the diagonals, you will going to get a center. That is the midpoint. Okay, so from this center point, okay, so imaginary line which is drawn from here, this is the apex of the pyramid, or vertex of the pyramid, what we can call. Okay, an imaginary line which connects from the your vertex or the apex of your pyramid to the base center of the pyramid, it is called as the axis or the center line of the pyramid. And how we can define a pyramid? A pyramid, all the pyramid which is having a base. This base depends upon the type of the pyramid. The example which I have taken, it is a square base we have. So it is a square pyramid. If it is the triangular base, it is called as the triangular pyramid. Pentagon base, pentagon pyramid. Hexagon base, hexagon pyramid. So like that. So, and then the complete body is bounded. This is the body of your the pyramid. The complete body is bounded by the, you can see here, the slant triangular faces. It is isosceles triangle. Correct? So the entire body is bounded by the slant triangular faces. This how you have to define the pyramid. That means here you can see all the base corner of your pyramid is joined to the vertex or the apex of your pyramid. Okay, so this is how we can define the pyramid. Once again, I'll define it. Any pyramid which has got a base and the entire body is bounded by the triangular faces. If the square pyramid is there, the body is bounded by the slant triangular faces, like this. So all are meeting at a single point. It is called as the vertex or the apex. So this is called as the pyramid. So I'll take this pyramid as the example. Now one by one we will going to discuss the example, different positions. So here also we have edge position, edge condition as well as the corner condition. So any pyramid, so you can see this is the base of the pyramid. It has got a square pyramid. It has got 1, 2, 3, 4 corners. It has got, and 1, 2, 3, 4 edge it has got. Okay, so like that, let me take up the first example, and only the difference here from the planes and solids. So can you remember this? So in projection of planes, so just for our reference, just to make it uniformity, whether it is resting on edge or resting on corner, we used to take it from the left side of you while drawing the initial position, correct? Here, so just for a change, so you all of us will take uniformly. So we'll take the, whether it is resting on edge or corner, we'll take that edge or the corner. Right side will take, even left side also we can take. Okay, only thing is for the second position we have to fix it properly. Okay, so we will make it uniformity. So whether it is resting on edge or corner, we'll draw that edge or the corner right side of us while drawing the true shape diagram or the initial diagram. So let me take up the first example. The square pyramid only I'll take example. A regular square pyramid having 35 millimeters side and 60 millimeter axis length rests on HP and one of its edges of the base, which is inclined to VP at 30 degree and the axis is inclined to HP at 45 degree. Draw the projections. This is what the question he has given. So from the question is clear that he has given a square pyramid which is having a 35 millimeter base side. All the four sides are equal, and the axis side. Axis, what I told, axis is an imaginary line which is drawn from the center of your base to the vertex or the apex. Okay, so this axis height he has given, this particular height he has given, that is 65 millimeter, and he says it is resting on HP with one of its edges of the base. So any one of the edge you can take, and you can take that edge on right side of you to draw the true shape diagram. So with this, so I'll keep the edge on my right side and keep it on HP like this. Okay, I need to draw the true shape diagram in this position where it is resting. It is resting. Now onwards in the planes. Okay, we have discussed the plane surface resting on both HP as well as VP. Also, few cases we have discussed. But whereas in this projection of solids, we will discuss always a case where it is resting on HP only. Okay, so it is now as per the question, I have taken the square pyramid and it's resting on one of its edges of base on HP. So I kept the square pyramid on HP such that the edge should come right side of me. Okay, in this position I have to draw the top view as well as the front view. When you see from the top this square pyramid, it looked like a square, correct? And it looked like a square, and this slant edges, these four slant edges look like a diagonal in this case. Okay, that is what I have written here. First you draw a square of 35 millimeter in the top view, the true shape diagram. Okay, then draw the diagonals. So the base you can call it any name. I have taken it as A, B, C, D I have taken. Okay, and then here after getting the center point, I will call it as the base center point as the O1 and apex point as the O. That means this base center point I am calling it as O1 and this apex point I am calling it as O. Why I have written O1 within the bracket? When you see from the top, this point, the base center point I cannot see. So that's why it is put it within the bracket. So this completes your the top. You will see this square pyramid from the top side. It look like a square, and the slant edges will look like a diagonal. Even the diagonal also you should make it thick. It's a visible edge. So this completes your the top view. Coming to the front view, how to draw the front view here? Draw the vertical projector like this from all the 3 points. That is from the center. From this point, you draw the vertical projectors like this. See, you can draw the vertical projectors like this from all the 3 points. And from here, XY line, you take what is the axis height he has given? 65 millimeter, correct? You take 65 millimeter from here, draw one horizontal line, or else from the center. You take, this is the center axis line. Now, this is how you have to represent the axis line. One lengthier line, one shorter line like this. Okay, so from the center you draw a vertical line, and this vertical line you cut 65 millimeter, and this is the point 65 millimeter. After getting this point, you draw a line between this vertex or apex to these two ends. So in the front view, how exactly it looks? If you see this the square pyramid from the front side, it looks like an isosceles triangle. That is what I have written there. You see this, again I'll repeat it. See from the front side, it look like an isosceles triangle. That is what I have written here. You can see, and also you are looking from here. How to transfer the corresponding points? We are looking from here for the front view. A point and D point you can see. That's what A dash and D dash is written without the bracket. Whereas the B and C point you cannot see from the front side when we are looking from here. So that's why B dash and C dash should be within the bracket. And the apex point O I have taken, that's why the apex point I am calling it as O dash in the front view, and the base center point O1. So here it is called as O1 dash. Here also I put it in the bracket. Why means because even when you see from the front side, when you are looking from here, this base point center I cannot see that. So this completes your the initial position at the true shape diagram. This is called as the true shape diagram. The diagram of your the front view and top view of your the pyramid. So whatever the dimension which he has given. So next the part of it, whatever he has given. So he has given the axis is inclined at how much? He has given the axis is inclined at 45 degree to HP. Always the HP inclination you have to consider here now onwards, because in the planes we have discussed, if it is resting on HP inclination you have to consider first, then the VP inclination. Correct? And same thing, if it is resting on VP inclination you have to consider first, then the HP inclination. Here there is no confusion. So always the solid is resting on HP. That's why in the second position HP inclination only we should consider it. So with the for this, so one more the clue let me give. So your base, this is your base and the axis. Axis is the center point which joins from the center of your base to the apex. Your base of the pyramid and the axis of your pyramid, they are mutually perpendicular to each other. Is it true? Once again I'll repeat it. The base of your pyramid and the axis of your pyramid, they are mutually perpendicular to each other. Here in the front view I can see here, this is the base now. This is the base. Just look at this cursor, the base, and this is the axis. So axis and base, they are mutually perpendicular to each other. So here in the question he has given the axis inclination, correct? So directly I cannot do any trial and error. I cannot take the axis inclination directly. Instead of that, so with this hint whatever given, see the base and the axis are mutually perpendicular to each other. I can fix the base inclination automatically. The axis inclination I'm going to get. How to do this? Next step. The same XY line, right side you take any one of the point and draw. So what is the axis inclination he has given? 45, correct? Axis inclination is 45, and axis and base, they are perpendicular, mutually perpendicular to each other. And what about the base inclination? This becomes right angle triangle, correct? This is axis inclination. Axis and base are mutually perpendicular to each other. What about this angle, base angle? It is 90 minus 45. It is 90 minus 45 means 45 only. So what you do, you take any one point on the right side of your XY line and take that point and then draw a 45 degree line left side of you like this. So left side of you can draw the 45 degree line. Okay. And then after drawing this 45 degree line, you have to redraw this isosceles triangle such that this isosceles triangle base, this is the base, should rest it on this 45 degree line. That's all. Without changing its shape and size, including the points. How to redraw this? So this point which is resting on the XY line, that is HP, you take that as the D dash and C dash point. Okay. And this 45 degree line, you take this length. With the help of your compass, this is the center, you cut it here. You are going to get A dash and B dash, correct? And similarly, from this point to this point you take, and from here you cut an arc. So you are going to get this point. Okay? How to redraw it? From this point, you draw a perpendicular line to this base. Draw a perpendicular line. You take 65 millimeter, cut this perpendicular line and call that as the O dash point. Once you get this O dash point, join this like this. In a manual method you have to redraw this. So now you can extend this axis till it cuts the xy line, and you can show the axis, the inclination, because he has given the axis inclination. For my convenient, I have taken the base inclination. That's all. So I hope you have understood this. So after doing this, so how to draw the top view corresponding to this? So to draw the top view, so nothing you have to do. You have to draw the vertical and horizontal projections from the previous front view and top view. That's all. To draw the top view, draw the vertical projectors from all the points of your the front view like this, and draw the horizontal projector from all the points of your the top view, and name the intersection points. For example, A is here and A dash is here. This is A. B is here, B dash is here. This is B. C is here, C dash is here. This is C. D is here, D dash is here. This is D. O1 is here and O1 dash is here. This is O1. O is here, apex point. O dash is here. This is O. So after getting all these points, we have to see which the edges we can see and which edges we cannot see. That is visible edges and hidden edges we have to see. So let me show you with the help of this. So you are tilting it like this. The axis is inclined at 45 degree, as well as base is also inclined at 45 degree. So when you are looking from top, the base side 1, 2, 3, all these three sides you can see. The base side which is resting on HP, that you cannot see. So the base you are looking from here, correct? The base edge which is resting on HP, this base edge you cannot see. So that's why, which is that resting on HP? CD. So that's why you mark this C to D edge as the hidden edge, because that we cannot see. And remaining three edges you can make it visible edge. This completes the base. And in pyramids, you remember, after drawing a base, all the corners of the base should be joined to your vertex. This is what you have to do it. And when you are looking from here, all the four slant edges you can see here in the front view. So that's why. And also say while marking this visible edges and hidden edges, one more clue I'll give. Always the boundary edges or outline of the solid should be visible edge only. I cannot draw a dotted line for the outer line, for this line or this line or any other line. For example, for this solid, which becomes the boundary line or the outline of the your drawing, this B to A to D, D to O, O to C, and C to D becomes the outer line or the outline or the boundary, the edges. Always for any solid in any view, outer line, outline or boundary edges are always visible. So in this case, so you are looking from here, correct? So A to B you can see, A to D and B to C you can see. Let me, so this is with respect to the model. Without using that, you are looking from here, correct? The base edge D to C we are looking from here, which is behind you. You cannot see that. That's why the base edge C to D is the hidden edge. Coming to the slant edges, A to B, A to O and B to O you can see, A to O, B to O, and you are looking from here, it seems, it looks D dash to O and C dash to O dash we cannot see, but I cannot draw it with the dotted line here, but we can see that. That's why we have to draw a visible edge only. And at the end, axis line also we have to consider in all the cases. So O is the vertex point, O1 is the base axis point. We join this O1 to O with the axis line representation in this way. So this completes your the top view. Next, coming to the next, what he has given, he has given in the question that the base edge which is resting on HP, which is the base edge which is resting on HP, CD. CD is the base edge which is resting on HP. The CD is inclined at an angle of 30 degree, it says. Correct? The same CD, now it is perpendicular to the XY line or VP. He says the CD which is resting on HP, it is making an angle of 30 degree with respect to VP, he says. For the third condition or the final condition, you can draw 30 degree line in any direction. Okay, for my convenient, I have drawn the 30-degree line in this direction. Draw a 30-degree line from the XY line like this, and you have to redraw this previous top view such that this CD should come on this 30-degree line without changing its shape and size. How to redraw it? Let me explain. You take any one of the point on 30-degree line, just observe the cursor, call that as the C. Then C to D distance you take with your compass and cut it here. You'll get D. Okay, it's a rectangle, so it is the angle between them are 90-degree. Then from C and D you draw a perpendicular line or the 90-degree line to 30-degree line. And take this C to B and D to A distances are same. You take with the help of your compass C to D. C as the center, you cut this the 90-degree line, perpendicular line. From D as the center, you cut this. You will get A and B also. A and B also you will going to get. Then from here to here, the central point. From here to here, center point you take and cut it here. You will get this. After getting this point, you take this height from this point to O. You draw a 90-degree line from this point, and this as the center, this as the radius. You cut an arc here. Call that as the O. That is your apex point. Similarly, on the other side of 90-degree, from this dotted line to O1, you take the distance from here. You cut this 90-degree line. You will get O1. Now, after getting all the points, without changing anything, including the hidden edges, visible edges, and the point, everything you have to transfer it here. That's what I have drawn here. Without changing anything, I have redrawn this the top view such that this CD edge which is resting on HP is making an angle of 30-degree with respect to VP. Okay, so this completes the top view. So after this, so to get the final front view, what you have to do? So you have to keep on draw the vertical projector from all the points of your the top view like this, and you have to draw the horizontal projectors also from the all the points of your front view also. Now coincide the points and name it. A is here, A dash is here, this is A dash. B is here, B dash is here, this is B dash. C is here, C dash is here, this is C dash. D is here, D dash is here, this is D dash. O1 is here and O1 dash is here, this is O1 dash. O is here and O dash is here, this is O dash. So this completes your the orthographic projection of this square pyramid. And at the end, so you have to see this solid, okay, and including the hidden edges, visible edges, you have to see. Let me show you from the sketch. You are looking from here, correct? You are looking from here. So the entire base you can see here. Entire base you can see always. So that's why A dash, B dash, C dash and D dash you can make it visible edge. And coming to the slant edges, you are looking from here. So D to O you can see it is very nearer to you. A to O you can see, B to O you can see, as well as so what about C to O? You are looking from here. The C to O is behind you. So that's why the C to O you cannot see. So that's why the C to O is hidden edge. The only one slanted that you cannot see, that is nothing but your hidden edge. And at the end, O1 dash to O dash, you have to join it with the axis line representation. So exactly the final position, this is the initial position you have taken. Second position, only this edge you cannot see. Final position, if I take it like this, final position, the complete base I can see. So let me explain you in your only. So you have tilted it like this, and then now we are tilting it like this. This the base at this inclined at 30-degree to VP. Now the entire base you can see, correct? The slant edges 1, 2, and 3 you can see. You cannot see this slant edge which is behind you. So that slant edge you have to make it a hidden edge. That's all. So this how you have to complete the orthography projection of the pyramid which is given to you. Second one. So let me take one more example. Same square pyramid, corner condition let me take in this case. Just read out this the pyramid. So in the second question, so what is given? A square pyramid, same 35 millimeter side and axis 60 millimeter, rests on HP on one of his corners of the base he has given, such that the two base edges containing the corner on which it rests makes equal inclination with respect to HP. For any the corner condition, this is the common the information which is given. Okay, that means so when this resting on the corner, I cannot rest it like this or rest it exactly. So this both the sides of your corner should be mutually the it is the base edges make equal inclination on either side. So I'll explain that once again. If this is a common information, draw the isometric projection of the pyramid when the axis is inclined to HP at 40 degree and VP at 30 degree. This is what it is given. Okay. So as usual, so let me take the square pyramid and says it is resting on the corner. So you take corner on your right side and rest it on HP like this. The top view, you draw the square corner condition, so that corner should come right side of you. When you are looking from the top, the base of your pyramid look like a square and this slant edges will look like a diagonals. You draw the diagonals and make it visible edge. Okay. Next, after this, to get the front view, you are looking from here, correct? If you are looking from here, then so here also in this case also it look like a isosceles triangle with this edge visible. Here in this case, the axis you cannot see in this case. So first, so you draw the corner condition. You know how to draw the square corner condition. Draw an horizontal line. Take any one point here. Draw 45 degree line on either side. After drawing 45 degree line on either side, what you can do? You take 35 millimeter. This is the center. You cut an arc on the 35 degree, the 45 degree line. From here, you cut horizontal line. From here, cut horizontal line. You will get 4 points. You can join it, and you will going to get a square in the corner condition. That is A, B, C, D. You can name it and draw the diagonals. Center, the O1 is the base axis point, O is the vertex or the apex point. So after this, how to draw the front view? You draw the vertical projectors from all the points till it meets the XY line. From the center, you draw a vertical line and axis height here it is given 60 millimeter. You take 60 millimeter, cut it here. That is your vertex or the apex. Now you draw a line from a vertex or apex. Here, why I am drawing a visible edge here? Because one of the edge will coincide on this axis. So let me give you this information also. Whenever visible edge and hidden edges coincide with the same the line, we have to give the importance for the visible edge. Okay. So if the visible edge and hidden edges are here, even if I draw the dotted line here, I cannot see that. And in this case, the axis line is coinciding with this line. Even if I draw the axis line here, already the visible edge continuous line is there. I cannot see that. So that's why the axis is there, but I cannot represent it. So it look like a triangle like this. And you are looking from here in the front view, point A, B, A, D, C, you can see. You cannot see B. That's why the point B is written within the bracket. The axis point O1 you cannot see. That's why within the bracket O1 dash. Axis point O, you can see the vertex point O dash. This completes your the front. This is the initial position that you have completed. So it is exactly it is placed like this. The front view look like a equilateral isosceles triangle. Top view is a square in the corner condition. Next, he has given the inclination with respect to HP. How much? 50 degree has given. He has given 40 degrees. Sorry. So in the last previous example also I have given the base and the this is your base and axis are mutually perpendicular to each other. If the axis is 40 degree, what about the base? 90 minus 40. Base I should take 50 degree. So you take any one of the point on the XY line, draw 50 degree line. This line which I have drawn, it is 50 degree line which I have not mentioned here. This is 50 degree line. Okay. So after drawing this 50 degree line, you need to redraw this isosceles triangle such that so this base of your the triangle should come coincide or come on this the 50-degree line. How to do that? So this corner point you can take it as C dash, then C dash to A dash you take, and from this as the center you cut 50-degree line, you will get A dash. Similarly from here to here, this distance you take, from here you cut it here and transfer all the points here. Okay, after that from this point you draw a 90-degree line to this base, or for this 50-degree line you draw a perpendicular line. On this perpendicular line you take axis size 60, cut this, you will get this apex point or the vertex point O dash. Now you join it like this without changing anything. You need to redraw this the triangle such that the base should come on this 50-degree line. After drawing this, you can extend this axis line. You can extend this axis line till it meets the XY line and show it. So the axis is 40-degree, so which he has given. But for my convenience, I have taken base inclination 50-degree. So it is correct. So after this, so you need to draw the top view for this. What you have to do for this? You have to draw the vertical projectors from all the front view which I have drawn, and draw the horizontal projector from all the top view points like this. Now coincide the points. A is here, A dash is here, this is A. B is here, B dash is here, this is B. C is here, C dash is here, this is C. D is here and D dash is here, this is D. O1 is here, O1 dash is here, this is O1. O is here, O dash is here, this is O. After marking it, here also we should see the base as well as the slant edges one by one, whether we can see or not. See, so initial position you have tilted it like this. Okay, I have tilted it like this. When you see from the top, the base edges 1, 2, these two base edges you can see. You cannot see the base edges which are starting from the corner. So always you remember, any corner condition example, whether it is prism or pyramid, the corner condition, second position. So the edges which are coming out from the corner that you cannot see in the top view. So here the two base edges you can see, that you cannot see the other two base edges. Coming to the longer edge, this slant edges 1, 2, 3 you can see. You cannot see the slant edge which is starting from the corner. How to analyze from this sketch? You are looking from here, correct? Coming to the base edges, A to D and A to B you can see, which becomes outermost boundary line. What about the B to C and T to C? We cannot see that. That's why C to B and C to D are hidden edges. Coming to the slant edges, A to O you can see, it's nearer to you. B to O and D to O also you can see, it becomes outermost boundary line. And C to O we cannot see that. C to O we cannot see that, but I cannot show it here. Already A to O visible edge is there. Even if I draw C to O hidden edge here, I cannot see that. It will coincide with the visible edge. And axis line also I cannot show here, but axis line it is there. O1 to O. But already visible edge is there. I cannot show that. So this completes the second position. Now coming to the third position. So here the inclination whatever he has given, it is a true inclination. Correct? So in the planes, the chapter also we have discussed, the true length is given. We have to take the locus and then you have to take the apparent length, all those things. In the question, if it is given the top view of the axis is inclined, in such a cases, so we can take directly that as the apparent inclination. Here the true inclination is given with respect to VP also. So he has given 30-degree. So what you can do is, on right side of your XY line, in any direction you can draw a 30-degree line. On this 30-degree line, you take any one of the point on the 30-degree line and call that as the point O. Because this axis inclination, whatever it is given, it is the true length of the axis. From this O point, you take which is the true length of the axis, 60 millimeter is the true length of the axis. You take the true length of the axis and cut this 30-degree line. So here you are getting it. This is the 30-degree line. You take any one of the point, call that point as the apex point O. From this point you take 60 millimeter actual length or the true length of the axis. You cut it here, you may get somewhere else here. Once you cut this 30-degree line, you draw a locus line, horizontal line. We can call this as a locus line. After getting this locus line, which is the apparent length of your the axis, from this top view, O1 to O distance you take. So this distance is your apparent length of your the axis. You take this O to O1, the apparent length of the axis, with the same center O, you cut this horizontal line. You cut this horizontal locus line. After getting this locus line, you join this with a thin line at the beginning, O to O1. So, and if you extend this till it meets the XY line, so whatever the angle that you are going to get, that is the actually the apparent inclination. After doing this construction work, once again I'll repeat this step. First, after drawing 30-degree line, take any one of the point. We call that as apex point. You take the true length of the axis, because the true length is given 60 millimeter. From this O, you cut an arc on this 30-degree line. Once it cuts the 30-degree line, you draw the horizontal line, that is a locus line. After drawing a locus line, you take the apparent length of the axis, that is O to O1. With the same center, you cut this locus line. Now you join this O to O1. Now what you have to do, you have to redraw this, the top view, such that this O1 should come on this O1 which you have marked without changing its shape and size. How to redraw this? So O1, you know, O1 point, you know, yes, and you extend this line a little bit here. From O1 to C and O1 to A distance is same, correct? So you take the distance with the help of your compass. From O1 you cut this, and with the same O1 you cut it. You will get A and C point. This is A and this is C. Similarly, from C you take the C to O. Already O is there, no need to get that. And then after getting this O1, you can draw a perpendicular line to this line. From passing through the O1, you can draw a perpendicular line to this, like this. After drawing a perpendicular line, you take this O1 to B or O1 to D distance is same. On that perpendicular line, from this as the center, you cut on either side. You will go to your own the method also you can use it. Okay. You will going to get B and D. Or else if you want to draw with the help of arc also you can do it. A to B, C to B distance is same. A to D and C to D distance is also same. You take any one of distance. This as the center, you cut it on either side. This as the center, you cut it on either side. You will going to get B and D also. Any method you can use. And at the end, you, without changing anything, including hidden edges, everything, all the corners should be joined to the vertex or the apex. Now both should look similar. This completes your the top view. Now after this, so to get the front view, you keep on draw the vertical projectors from all the points like this, and draw the horizontal projectors from all the points of the front view. Coincide the points and name it. So A is here, A dash is here, this is A dash. B is here, B dash is here, this is B dash. C is here, C dash is here, this is C dash. D is here, D dash is here, this is D dash. O1 is here and O1 dash is here, this is O1 dash. O is here, O dash is here, this is O dash. Now you are looking from here. You are looking from here. So now you have to analyze which edges, base edges and slant edges you can see. So in pyramid, always if you are inclining in this way, that is the vertex is towards the XY line, the complete base you can see. So that's why A, B, C, D you can make it a visible edge. And coming to the slant edge, D to O you can see you are looking from here. Just make it visible edge. C to O also you can see. Yes. C to O also you can see. C to O will become outermost boundary line. What about B to O? Can you see this? You are looking from here. So this is behind you. So B to O you cannot see. That edge you can make it hidden edge. And O1 to O you can join it with a axis line representation. This so we can able to complete it. Let me show you with the help of this. So this is the corner condition you have drawn for. Second one you have tilted it like this. Here these two the base edges that you cannot see that you are represented. So at the end you have tilted it like this. So in this case the complete base you can see, correct, and the slant edges 1, 2, 3 you can see. We cannot see this slant edge which is behind you. So this completes your the isometric projection of this the corner resting the square pyramid. So we'll conclude for today only 2 examples because first class. So today itself we completed. Next class onwards 3 examples.